Hello world, this is Craig. My last video that I had this thing running, I had the MOD80 board with the 8080 on it and the EEPROM board where I was fetching instructions from. Checked that was all working okay. Since then I've populated all the rest of the boards and fired it up using all the rest of the system RAM and the system ROM and the I/O. And everything went very, very well, and that's in large part to having good instructions from Charles. There were no surprises when putting the boards together. The only problem I had was when I was doing the first fire up and reading off of the 1702 ROM board. I had a problem in that one of the chip selects in a ROM had bent under, and so it wasn't basically that chip was always selected, and so it was locking the bus up because it was always putting its value onto the bus. So the system locked up, tracked it down to that one chip, unbent the pin and put it back in, and everything fired up fine after that. So really, believe it or not, that was the only problem I had in bringing this thing up, was that one chip select on that 1702, and that was my fault, obviously. I pretty well did the standard build on this. There's nothing special. The only thing that I did was the address pins. Rather than solder jump those, I actually put in little pins and wire wrapped them so that I can have a little bit more flexibility without having to unsolder things. And other than that, this is done. I have the memory boards all done, the I/O done, the processor done, and the TTY and the restart board done. Except I have not put in the germanium diodes that kick the address, the start address and the interrupt address on the bus when there's an interrupt. So I haven't put those diodes in the restart board, so it always just starts at 0. And then I haven't populated my 8008 or my buffer board yet. So right now I've just been focusing on the 8080 board. Simply, it's a lot easier for me to code that and put the code in and do the rest of the diagnostics tests with that 8080 board. Okay, I also haven't started at all the backplane. So the PROM programmer, I haven't started that at all. I was just, basically just checking all my boards out at this stage. So I've started writing a confidence test for this that I have in my EEPROM here, and I'll show you that in a second. For my confidence test, I wanted to have a serial port, so I used the input and output boards and 1-bit connected to my RS-232 to TTL adapter here. And I first got everything fired up using the input-output boards, and then I since switched over to using the teletype output on the restart board for the teletype. And I can do that because if you look at the schematic for that, for the teletype in, you can see this is fairly high input impedance. It's got a 1K going up to 5 volt, but a TTL has no problem pulling that down to ground in a logic low, and then in logic 1 there's nothing to keep this from going up to a TTL high. So my TTL output for my little serial adapter has no problem driving the input to the rails and getting the signal in. So to use this current loop driver as an output is a little bit different. What I found was that if I put about 900 ohms or 600 to 1,000 ohms from the teletype output down to ground, what will happen is when this output wants to pull it high, it'll go high, no problem. It runs up about 2 3/4 volts, which is high enough for the TTL to recognize it. And then when this output lets loose of it, that 600 ohms or 700 ohms will pull this down to ground quick enough that between the bits. So because of this capacitor down here, you can watch the voltage really has a slew rate, but with that capacitor I can still run this at about 1200 baud. So I have my teletype in and my teletype out directly connected to my TTL to RS-232 adapter here, and the only thing I had to do was put in this 600 ohms of resistance to ground. So I skipped into kind of the current loop to TTY, or current loop to TTL adapters for that. So anyway, now I'm using the teletype input output, and then I have all my ports back for whatever else I want to use those for. One thing I didn't realize until I started writing the confidence test is they've utilized bit 13 for 3 different things. One thing, if you look at the decoders here, you can see that they're decoding them exactly the same. Addresses 9, 10, 11, which are port address, and then they're using 13 for the enable. So when 13 is low, it's enabling the output. And of course, if 13 is low, 13 has to be, or 12 has to be high for an output. So in both cases, if you look at output 3, which is going to be port 1.3, you can see for the restart circuit, they're using that to control the relay in the teletype. And that's bit 0. So you can see here where they're taking bit 0 and they're using that as the data in, and then they're clocking that in with the strobe from the output for the port. But they're also using that over on the backplane for the programmer. So here's the same decoder, and you can see that they're also using the same addresses. They're using 13 on the enable, so when 13 is low, and output 3 is now going to output 1.3, and then if you look up here for the multivibrators, you can see that data bit 1 and data bit 2 control the 2 different multivibrators, the 15 millisecond and the 150 millisecond multivibrators. So all this means is when I was writing my confidence test code, and I was kind of willy-nilly putting things out to bit 13, I was playing with this relay port for the teletype, and not really paying attention to what I was doing, and or at least not paying attention to what the higher bits were. And I was actually turning off and on these multivibrators without even realizing it. So it's interesting that they triple purposed those, but just with a little bit of care, it's easy to take care of. You don't do the relay for the teletype that often, but when I do use the relay for the teletype, I just want to make sure that I clear those higher order bits and don't turn the relay on. So if you're writing your own code for this thing and you're playing with the programmer and all of a sudden your paper tape in the teletype turns off and on, that's probably why, because when you meant to turn on just the multivibrator, bit 0 may have been high and turning off and on this relay. So that was, I guess, the only thing interesting that I learned when I was writing that confidence test, something that I hadn't picked up in the hardware earlier. I have a confidence test that I've, for the most part, ported over from some of my Intel single board computers. I don't write this from scratch every time. I just pick the parts that are useful for this particular setup and then modify it, move the ports over and move all the functions over for this hardware. So if we look at the confidence test, I have a combination of confidence and diagnostics built into this at the same time right now. And I have 3 commands that allow me to send an output pattern byte to the 3 ports that I have, port 0, 1, and 2. I have a command that is a bad bit finder or a bad byte finder. It goes through the RAM and it finds bytes that aren't sticky. It does a memory dump between given addresses. I can fill RAM with specified value. I can just input from the ports. I can put in a list of addresses, and the program will then read from those memory locations, and it will give me the values of those locations. I can map the RAM. This will go from the lowest address 00 all the way up to FFFF, and find any locations that are RAM where they have a sticky. I can put something in it and then retrieve that back out again. I can do a RAM test where it goes to the known locations of the RAM and just does several tests of that RAM to make sure that it's good from the starting up to the end, and then the RAM test just stops at the last memory location it finds it's valid. I can do a teletype test. I can show the version, and then just like where I can read memory locations from a list, I can write memory locations from a list. So just to look at some of these, for example, right now I have the output of port 1 just jumpered over to the input of port 2. So if I look at command 1, which is to set the output byte for the port, It allows me to enter a pattern, and so I'll put in like an A6. It shows me that that's my pattern in binary, and then it reads in port 0, port 1, and port 2, and I can see that port 2 matches what I put it on the output. So I can just do this continuously and make sure that that port is following. Okay, so I have that for each of the ports. Carriage return takes me back to the main menu, or takes me back to the prompt. The bad bit finder, if I look at the bad bit finder, my memory, my RAM is at 2800. So if I say start from 2700 and go up to 2900, so you can see what it does is it reads those and it's saying, well, those are all bad RAM. It fails all of those until it gets up to 2800, and then it passes all of the RAM after that. I think I'll probably come in and modify this a bit to, instead of just giving me an F for fail, it'll give me a value of which bits in that failed, which is useful when we have RAM that is one bit per chip. Let's see what is next on the commands. The memory dump, there's nothing really special about that. Let me just put in, I can put in a starting address. So this is the confidence program itself. And it just reads it and then gives the, if it is a printable ASCII character, it'll just print it over on the right-hand column what that character happens to be. So this was useful in just going in and reading, for example, all the 1702s that I put in to make sure that they were, just to see what was in them. I can fill the RAM, nothing special there. I can take 2800 to 2900, and it gives me a value, and let's say I want to put in a 1, and it fills the memory, and then it comes back. Input from the ports, it pretty much just shows me what the values of the port are. So this is just like when I was writing to the ports, it's the second half of that. Teletype tests gives me the printable character set, upper and lower case, and then it just echoes back whatever character until I press an escape. Oh, I forgot to do the list and toggle from memory locations. So this is really useful if I'm having problems with an addressing, or if for some reason I've messed up and I can't find where something is in the system, and I just want to go out and have it toggle sequential memory locations. So I can put in, for example, I want it to toggle 2800 and 2801, 2802, but also I want to jump up and have it toggle 2900, 3000, 5000, and then hit a carriage return. And so now what it does is it goes out and it's just reading those values. So it's continuously reading those values, updating them on the screen here. So if they happen to change, it'll give me the new value. And then every time that it starts from the first value in the list again, it strobes the interrupt enable pin so I can sync my logic analyzer with that. So this is just a diagnostic. If I'm having problems with a chip select for some reason, this is a good way to do that. Map RAM, as I mentioned before, that's fairly basic. It just goes through all of the possible addresses and does just a few tests to write something into that memory location and then see if it can read it back. If it does it, it retries it, and it does that a few times. And it will output a map of the RAM. It doesn't have to be contiguous. It'll just tell you even individual locations of the RAM, or it'll tell you what the blocks of RAM are. The RAM test just starts from the known bottom of the RAM and goes up until it gets a bad value, and then it repeats and just counts how many tests it's gone through. The write pattern is exactly the same as the read pattern, except it allows me to, you put in the list and then you put in the value that you want to go into that memory location, and then jump to 0, restart. So I fill this out as I go through the hardware and I find more things. So I'm going to put in next the ability to turn off and on the programming ports, the multivibrators, read from the ZIF socket on the programmer, and some various things like that. And then probably I'll be pretty much done with the confidence test for the MOD80 version, and then I'll start over on the finish up my hardware on the 8008 and write a little confidence test for that. Okay, so that's just where I am on this, and as I said earlier, this has gone really well. There haven't been any hiccups. It helps to be just a month or so behind Charles and anybody else that's putting these systems together. So they have found any issues on the board, and he's put it into the build instructions. So this has just gone very smoothly. It's just been a fun project to do. So as I mentioned, now I'm going to dig in and do the backplane. I have an order from DigiKey that I haven't placed the order, but it's got some parts that I need for the backplane, my transformers for the high voltage and so forth. Go ahead and place that order, get that stuff in, and finish up, get it mounted in a box, and get ready to move on. Okay, so that's all for today. If you have any questions, let me know, and thanks for watching. Bye.